Welcome back to our discussion on advanced gold explorers and developers with Mickey from Mercenary Geologist and Rod from Cipher Research. Last time we agreed that the quality project is the most important aspect of company valuation. The basic equation to follow here is value is equal to the quantity of ounces in the ground times their price. Cipher Research benchmarks this price by using comparable market transactions or takeovers historically. Mickey takes on a peer comparison approach. Gentlemen, let's talk about the other variable in our equation, the quantity. Where do we start here?
Well, for me, it's all about the quality of ounces, not the quantity of ounces. And I like to use an axiom: every good geologist knows that grade is king.
For Cipher, it's very similar. Before there is any quantity of ounces, they must pass a quality test, as well as suffer any adjustments that we impose on them. As for grade being king, we don't think it's quite that simple. For instance, if all things being equal, we would rather have a open pit deposit grading 0.8 grams per ton in Nevada than one grading 1.6 grams per ton at 4,000 meters in Kyrgyzstan. And similarly, for an underground mine, we would rather have a vein on the surface grading 3 to 4 grams per ton rather than one grading 6 to 8 grams at 1,500 meters depth.
Well, I agree with that. For me, grade is a first cut pass where I can eliminate a lot of resources. But you also have to take in many other factors, including the geometry and depth of the ore body, the mining method, the metallurgy, and the infrastructure to develop a quality resource. And this is where the technical expertise and experience really pays off.
Once these factors are understood, then we can turn our attention to the variables used in calculations of a resource, such as the cutoff grade and the price assumptions used for gold that can have dramatic effects on the overall size of a resource. And the cutoff grade itself is important to understand because it is the value required to break even mining and processing material.
So I like rules of thumb, and one of Mickey's rules of thumb is that the cutoff grade needs to be high enough, and not only that, but the average grade of the deposit should be at least 2 times the cutoff grade. So if you have a cutoff grade of half a gram per ton, then you want a minimum average grade for the deposit to be at least 1 gram to be mineable.
To better illustrate the effect of cutoff grade on the resource size, we have prepared a couple examples. 2 different open pit mineral deposits. The first one, technical report using $1,400 gold price and 0.2 grams per ton cutoff grade.
And it's important to pay attention to the price assumptions of gold because a higher price of gold used results in a lower cutoff grade to define a resource. For instance, if we use $1,000 per ounce gold price and a half a gram cutoff, that equates to a $16 per ton break-even or cutoff grade. If we move the price of gold up to $1,500 per ton, using the same $16 cutoff grade per ton, the cutoff grade now can be reduced down to a 0.33 grams per ton.
Well, right away I look at this resource and I look at the grade, and it's just not high enough, in my opinion, to ever make a mine, especially because I know it's in a remote location with little infrastructure, and not only that, but at high altitude. Big red flag for me in this instance is the cutoff grade of 0.2 grams per ton. That's not mineable except under very ideal conditions, perhaps an open pit gold mine in Nevada or Mexico.
Yeah, so let's take a closer look at this resource. And the published resource at 0.2 gram cutoff grade is 248 million tons at 0.42 grams per ton, which is 3.3 million ounces of gold. So when we adjust that to a more realistic 0.5 gram per ton cutoff grade, we go down to 58 million tons grading 0.73 or 1.4 million ounces of gold. That's a 58% decrease in the total gold and almost an 80% decrease in the total tons.
So that means that 1.9 million ounces of gold is lost in this instance when we move the cutoff grade up to a legitimate level. And imagine what would happen if we took today's gold price, range bound between $1,100 and $1,200 an ounce, that destroys even more ounces as mineable in this instance.
The second example is from a published resource using $1,100 for the price of gold and 0.35 grams per ton cutoff grade.
An initial look at the average grade of this deposit, a little bit more than a gram per ton, and a cutoff at 0.35 grams per ton, that would intrigue me. If we adjust for comparison purposes to a 0.2 grams per ton cutoff, that still gives an average grade of 0.72 grams per ton. Now that's still too low grade to mine, but it does indicate the quality of the resource versus the previous example.
So let's take an even closer look at this resource then. At 0.2 grams per ton, the measured and indicated resource is 360 million tons at 0.72 grams per ton, or 8.4 million ounces of gold. And when we adjust that cutoff grade to 0.5 grams per ton, the resource becomes 141 million tons, grading 1.35, or 6.1 million ounces of gold. That's less than a 27% decrease in the total gold and only a 50% decrease in the total tons.
So this is a deposit that I like. It's got a very strong resource reserve base. It's got good grade. It's got a legitimate cutoff grade, and it also has good infrastructure.
So the second example comes from a project that was acquired by a mid-tier gold miner. Is it fair to say then, if the quality of the deposit is there, the resource size is less sensitive to changes in the cutoff grade?
Yeah, absolutely. I believe that's a very good definition of quality of ounces and a very good rule of thumb for investors to use.
Mickey and Rod, thank you for sharing your thoughts. I look forward to concluding our discussion, where we're going to put everything together with a case study.